The broadcast is now starting. All attendees are in listen-only mode.
Hello, and welcome to the Assess Insight webinar for March 2021. I'm going to give a little bit of background before we start about the Assess Initiative for those who are not familiar with it. Many of you are Assess Initiative members, and some of the attendees are not, so I'm going to give a little bit of background before we start with this month's webinar. The Assess Initiative stands for Analysis, Simulation, and Systems Engineering Software Strategies, and it was formed in order to significantly increase the use and benefit of engineering simulation across multiple disciplines and across multiple different industries. The concept behind the Assess Initiative was bring together the key thought leaders to focus on the strategies and the issues that represent strategies that are necessary to enable us to break through to the potential significant growth in both utilization and in benefit of simulation. The clear roadblock is that not enough people are using simulation and it's too difficult to use. There's other roadblocks that have been defined as well. The Assess Initiative was broken into 8 specific themes to discuss how to move forward. The first theme is aligning commercial business, government, and academic activity. The second is business challenges. The third is engineering simulation credibility. The fourth is democratization of engineering simulation. The fifth is generative design. The sixth is integration of detailed simulation and systems level simulation. And the last but not least is engineering simulation digital twins. And so we've worked with those 7 different themes in order to break out what are the strategic thinking, not the tactical implementation or the deployment issues, but at Assess, we're focusing on what's the strategic thinking, the strategic approaches, what are the strategic issues that we need to deal with so the community together can move forward. Part of that whole process is an Assess Congress that we put out every year, which has been put on hold due to the COVID pandemic. We are hoping to start that again in the spring of 2022. We've also planned a forum with the ASDL in Atlanta, which is also now scheduled for 2022, related to digital twins. And we've implemented this series of Assess Insight webinars in order to provide information on several of the different themes and topics that are related to Assess. So for this month's webinar, I want to introduce the speaker. The speaker is Malcolm Panthicky, and Malcolm has 30 years of experience in the CAE software industry. And it's a pleasure of mine to have spent many of those years working together with Malcolm on different projects, different activities. And so Malcolm has in the past led the Abacus CAE development. He's also founded Comet Solutions, and he's currently the VP of Analysis Solutions at Eris. And in his spare time, because he was bored with all the simulation stuff, he also founded the Revolution in Simulation, which is an online community for next generation simulation usage and expansion. And Malcolm is going to give you a presentation describing the revolution in simulation. Go ahead, Malcolm.
Thank you, Joe. Hi, everyone. Thank you for taking the time to be with us today. As Joe said, I'm Malcolm Panthicky, co-founder of the Revolution in Simulation online community and VP of Analysis Solutions at Eris Corp. I've been part of the simulation community for over 3 decades, i.e., I'm getting rather old now, and have focused my career on bringing the power of simulation to the entire enterprise, making it impactful to everyone who needs it, not just the experts. I'll begin with some background information on the nature of and the needs that drive the current revolution in simulation, and then provide an overview of this revolutioninsimulation.org online community that is steadily gathering momentum. Digital computers and simulation software were born almost simultaneously in the 1960s. And simulation software has pushed the boundaries of computing ever since. Computers have gone from the clunky, horribly difficult to use mainframes, boy, I detested those punch cards, to personal computers, to powerful desktop machines and local networks, to ubiquitous cloud computing that's elastic and all but infinite. Simulation has gone through many evolutionary and a few revolutionary changes as well. From the earliest matrix methods solvers to the powerful finite element analysis software starting with Nastran in the mid 1960s, moving to the era of parallel solvers on vector machines and other parallel hardware that provided a huge jump in terms of the throughput and the size of the problems that could be handled, to the era of CAD, where CAD entered the picture, radically changing how one could describe the shape of the models being solved. Around the early 90s was when CAD started, and CAD became the center of all the data that was required for simulation, to a focus on systems and system simulations, doing multi-fidelity and mixed fidelity calculations, moving to multidisciplinary solutions, and then finally ending with the era of enterprise simulation product lifecycle management. Through almost this entire period from the 1960s to the first half of the 2010s, experts were required to achieve anything useful on both the hardware and simulation software fronts. Nothing was easy or intuitive. Everything required delicate manual fine-tuning. A single large assembly mesh could take weeks of tender loving care to create. Yes, weeks. Validating simulation models often required PhDs for anything but the simplest physics, and data were obfuscated into hundreds of inconsistent and incompatible file formats. What a mess. The fact that the market for simulation software continued to steadily grow despite the high total cost of ownership and the need for high levels of expertise is testimony to the value that simulation provided. And especially for the development of complex products, simulation became essential. However, the fact that only experts could run simulations left much to be desired. A 2014 study by the UK research firm Kambashi found that worldwide, fewer than 1 million engineers were actually using simulation software. A huge number of engineers didn't have the expertise that was needed to directly leverage the power of simulation. There developed a clear segregation of simulation engineers from all the other engineers. Simulation engineers had to become experts in not only the general concepts behind the simulation algorithms, but in the use of particular tools that solve particular physics at particular levels of fidelity. And this took a lot of education and a lot of time in the field, creating a high barrier to entry. Hence, the limited supply of simulation experts and the fact that most companies had just a few of them resulted in simulation becoming a well-known bottleneck in the product development process. And not surprisingly, physical testing continued to be the go-to method to validate designs before they were manufactured and shipped out. What does it take for a complex, though obviously useful technology to cross the chasm, so to speak, between limited use by experts and mass usage? It's reasonable to assume that technology experts with PhDs and early adopters will always be in very short supply. Consider the navigation app that's now ubiquitous on smartphones. If one had to be an expert in miniaturized electronics, networks, wireless communication, and GPS and other communication satellite esoteria to use such an application, there would be few takers, if any. However, what makes these apps usable and useful to everyone is that they're simple to use, accurate, reliable, cheap, and highly accessible. And those, in a nutshell, are the characteristics of a highly complex technology that has crossed over to mass usage. When using the app to go from A to B, you don't have to think about the mind-blowing technologies all working smoothly together over vast distances and in real time to make it all work. The democratization of a technology is achieved when it truly vanishes from sight and mind. In 1996, Mark Weiser of Xerox PARC, a visionary and computer pioneer, spoke of the upcoming age of ubiquitous computing when technology recedes into the background. He was certainly a bit ahead of his time at that time, but I believe we're entering that era for both computing hardware and simulation software. And yet, somewhere in the background, I can hear the simulation experts insisting that only the experts should use simulation software. Now, we've had a few revolutions in simulation since the 1960s and the 70s. There's one happening right now, and we're already a few years into it. Why is this revolution in simulation happening? How real is it? What's driving it? What are some of its main characteristics? Companies are exploring huge amounts of money in enterprise digital transformation as they face rapidly growing and changing market demands and new business models. These pressures translate into the need for more and more complex, multidisciplinary products with an emphasis on electronics and onboard software. The pandemic, unfortunately, is the exclamation point on these strenuous requirements, driving businesses towards digitalization and the need to support even more distributed work practices. Unfortunately, it's been a Wild West approach to digitalization. Lots of experimentation, no good strategies, disconnected enterprise projects, poorly defined goals that are not measured, and attempts to boil the ocean, resulting in about 70% of such initiatives ending in failure, according to Forbes magazine. 70%. And given that they estimate over 900 billion spent on these projects in 2020, yes, that's 900 billion globally, that's a colossal waste of money, waste of key resources and time, while markets keep moving forward rapidly, demanding more and more complex products. One major issue continues to be the highly siloed natures of businesses, processes, and data within these global enterprises. A divide and conquer problem-solving approach, that's often called reductionism, has been the accepted practice at large manufacturing companies for the last century. While this approach has benefits, it breaks down when complexity increases exponentially. What's needed is the addition of a diametrically opposite but complementary problem-solving approach called systems thinking. Suffice it to say that unlike reductionism, the core tenet of systems thinking is a holistic view of systems and their complex, nonlinear interactions that are driven by feedback loops. When systems thinking is applied to the global problems and goals of enterprise digital transformation, an important result is the need for an end-to-end digital thread of connected data across the entire life cycle of the enterprise and its products. And in addition, systems thinking, when applied to complex products, is empowered by the existence of pervasive, on-demand system simulation for the entire enterprise, closely and completely integrated into the digital thread. It is this new visibility for simulation, a driver for key corporate initiatives such as digital transformation, and the acknowledgement of its importance at the highest levels of the enterprise, plus the exploding demand for it beyond just the experts, that has fueled this latest revolution. The democratization of simulation is required and well on its way, with simulation experts and simulation automation playing absolutely critical roles. Now, while evolutionary change is constant and happens gradually over time, revolutionary change requires much more motivation and often occurs relatively quickly. Circumstances need to be dire before revolutionary change is forced to occur, Humans resist change, unfortunately. So this is never a simple process. In the case of simulation, the most recent demand for revolutionary change came from other new and exciting technologies that were essential ingredients of strategic corporate initiatives. For these technologies to work, they demanded the rapid automated execution of many orders of magnitude more simulation than the status quo could support. That experts were needed to run most simulations manually was simply infeasible and unacceptable. Robust and accurate simulation automation is no longer nice to have, but essential. So I'd like to pause for a moment to marvel at the 3D printed blade that you see here on the screen. A 720 horsepower hypercar, yes, 720 horsepower, from Divergent Technologies. I'm an engineer at heart who loves the seamless marriage of engineering, technology, and art, and this is a perfect example, announced in 2015. The key approach centers around the use of carbon fiber and aluminum alloys within a 3D printed chassis weighing just 100 pounds. The chassis weighs 100 pounds, consisting of aluminum joints that connect carbon fiber tubing. Suffice it to say that they made extensive use of advanced materials, generative design, additive manufacturing, and gobs of automated simulation for design optimization, structural safety, and the optimization of the additive manufacturing processes to create this 1,400-pound marvel that has a much smaller environmental footprint. That's half the weight of most modern sedans and mid-sized SUVs. The assembly of the chassis can be done in minutes, and the manufacturing process dramatically reduces pollution, materials, and other capital costs. The CEO of Divergent Technologies and its principal designer, Kevin Zinger, summarized this well. Computing power, material science, additive manufacturing, and simulation. When you combine those, you can get an optimized system. I encourage you to find out more about this amazing feat of engineering. And so, why is the demand for rapid and robust simulation automation going through the roof? There's huge increased demand for system optimization and design space exploration, requiring large amounts of automated simulation. There's the need to use simulation to create huge amounts of data that drive the machine learning algorithms that are essential for introducing artificial intelligence into the product development process. A focus on digital twins, hundreds, thousands, or even millions of products in the field that need to be monitored and simulated to do predictive maintenance and to help improve their designs going forward. The whole area of simulation apps, the need to create simple, graphical, highly targeted, fit for purpose applications that speak the language of the user and not the simulation experts, allowing users to run very complex simulations and do what-if analysis in targeted areas. The exciting new field of generative design, creating those wonderful organic shapes, all of which need to ultimately be simulated to ensure that they are structurally, thermally, and otherwise fit for purpose. The field of additive manufacturing, allowing you to take those fantastical organic shapes and manufacture them much more easily than you ever could in the past. However, simulation is needed, and lots of it, not only to optimize those additive manufacturing processes themselves, but to do quality control. And finally, the technology that simply cannot get enough simulation done quickly enough. Simulating connected autonomous electrified vehicles. This simple graphic from a paper published by MSC Software and CAD LM says it all. It would take 9 years to manually test these vehicles over 14 million kilometers of roadways. And yet, with automated simulation, Waymo can now virtually test these vehicles over 13 million kilometers in a single day. Manual, time-consuming simulations done one expert at a time, one model at a time, just simply doesn't cut it anymore. We're now in the midst of this revolution. The goals are simply stated: to increase the use of computing power and simulation by orders of magnitude, driving the experts to create robust and safe simulation automation templates that can be used by anyone or any technology that needs it. Yes, simply stated, but not necessarily simple to implement. Ironically, while the opponents to freeing up the use of simulation have been the experts, this explosion of the use of simulation beyond them makes these high-priced and scarce simulation experts exponentially more valuable. Now, they're not constantly swamped doing the mundane day-to-day simulations, but work on packaging them safely for extensive use using rigorous simulation governance principles, and also on the really hard cutting-edge simulations that are always required to move the discipline to ever greater heights and utility. Now, to me, that sounds like a heck of a lot more fun. Now, this interesting 2015 McKinsey Institute study captures this revolution we're in the midst of through the lens of its estimated economic impact 10 years after the study in 2025. What you see is a list of the cutting-edge disruptive technologies that they then believed, this was 2015, would have the greatest economic impact in 10 years. And right near the top is the automation of knowledge work. And in fact, it has projected a huge economic impact. Its low level of $5.2 trillion in 2025 is the highest of all of these listed technologies. And this is exactly where simulation automation and the use of automated intelligent algorithms fits in. The reason automation of knowledge work was estimated to have such a tremendous impact is that it is required. This automation is required to move any complex technology to mass usage. And this is the crux of the revolution that we're now undergoing in the simulation world. There are some key elements of this revolution, and I've listed a number of them here. Starting out with something fairly esoteric, under the covers plumbing. The need for tool-agnostic data models to define data for simulation. Too long, simulation data have been locked into proprietary and tool-specific formats, and this is what's required to unlock the power of automation. Simulation governance, which is absolutely essential to ensure that all those automation templates are robust and accurate. Simulation automation itself, an absolutely key underpinning technology that's required by everything else that needs these gobs and gobs of simulation. Democratizing cloud computing, the same parallel revolution that must and is occurring on the hardware side, because all of the other gains in simulation are going to be meaningless without the ability to have cheap, elastic, and infinite computing power. Democratizing simulation itself, the ability to have robust, accurate, and safe simulation available for non-experts. More intelligent algorithms, generative algorithms, such as the ones seen in generative design, automated optimization, etc., that aid engineers in finding optimal solutions. The brand new introduction of machine learning and artificial intelligence to take huge amounts of simulation data that have been generated over the years and turbocharge decision making. And finally, the decidedly unsexy simulation process and data management discipline, bringing the power of simulation and simulation data to the entire enterprise via the digital thread, while enabling model-based systems engineering as a key ingredient for successful digital transformation of the enterprise. So where can you learn more about next generation use of systems thinking and simulation? Why are these topics now deemed critical for successful enterprise digital transformation efforts? Why are we now graduating from a narrow, siloed view of simulation to a much more holistic view that encompasses the entire enterprise and its partners and supply chains? These are the organizations where you can get some or all of these answers. The granddaddy of them is, of course, NAFEMS, formed in 1983, and now the recognized authority on all things simulation. They have a practical approach to simulation, training engineers in the basics and understanding how to best use the tools. Decades of simulation engineers have been trained by NAFEMS, which boasts a truly global presence. INCOSI followed, not too far behind, with a focus on systems engineering and systems modeling best practices, what we now view as a linchpin to a systems intensive approach to product development. More recently, the Assess Initiative was formed by Joe Walsh and a group of industry visionaries to shine a light on the technological, cultural, and business hurdles to the democratization of simulation. And finally, the baby of the bunch, the Revolution in Simulation online community, now with almost 3,000 members and followers from around the globe, and around 20 sponsoring companies that deliver cutting-edge simulation software, services, and expertise to help achieve the goals of this revolution in simulation. So let's talk some more about this Revolution in Simulation initiative. It was launched at the NAFEMS CASE conference in 2018. This online community and resources was founded to fill a critical gap. It is a free web portal that gathers in one online space all the resources that you might need to take your simulation investments to the next level. It focuses on next-gen simulation usage, helping your organization to maximize the impact of simulation on your business goals, including but not limited to the democratization of simulation and simulation automation. So let's take a quick look at what this website looks like. Here's the main page with some high-level topics leading you to case studies and the webinar series that we're now conducting. This area here keeps up to date with what's happening in the simulation industry, provides you with an easy one-stop place to go find things. Series of blogs that are often penned by the moderators that have been helping grow this community and its content, and some of the key resources that were just recently posted on the site. Case studies are an important resource that are available on the Revsim portal. We've gathered over 100 interesting cases, and the list keeps growing. You can find out what your industry peers are doing to increase the impact of simulation in their organizations. So here's the case studies page, and you can see a pretty large number of very interesting and up-to-date case studies gathered across the industry and posted here. Pretty wide range of software, wide range of industries represented by the end users, wide range of tools that are used and companies involved. Everything from traditional and complex products to data centers, generative design solutions, multi-physics computations in the web, etc. Please join the community and contribute your own success stories. A number of industry leaders have volunteered their expertise, knowledge, and time to be moderators over these last 3 years of a growing list of topics of interest. They curate freely available materials and reference them on the different topic pages. You can access these under the How It Works menu. I'm sure you recognize many of the people who have volunteered their time to help with this community. With the help of the moderators and our community, we've gathered together a large trove, hundreds of resources that you can access under the Resources tab. Here, you can access webinar recordings, blogs, articles, presentations, white papers, and even journal articles from a variety of sources. Very few of these are actually stored on the site. The site provides a short summary of a resource and then points to its original location on the web. So please contribute resources that you think would be valuable to the community. So here you see the very highlighted on the site, everything from business challenges and return on investment to democratizing HPC and simulation, the digital thread and SPDM, digital twins, generative design, multidisciplinary optimization and multi-physics simulation, simulation apps, automation, simulation governance and system simulation. Each of these pages, for example, simulation automation, has various resources associated with that particular topic area. And then the main resources page lists all the resources in one place that are all searchable. The search engine here allows you to easily find searches based upon these available tags or any other search string that you desire. And finally, Revsim has a growing list of sponsors, industry thought leaders that are an integral part of this revolution in simulation. The sponsors provide more than just financial resources to the community and are critical to the ongoing success of this initiative. They provide moderators, community outreach, thought leadership, and valuable content and resources that you see listed on the site. The site is now averaging almost 2,000 visitor sessions a month, with visitors averaging at least 3 minutes there. So very high quality set of visitors that have deep interest in the material available on the site. If you're a solution provider at the cutting edge of simulation, please join us at revsim.org, publicize your advanced offerings, and contribute to this growing community. Revsim's highly popular Learn from Your series webinar series, Learn from Your Peers, started late last year and continues through 2021. The series focuses on case studies, providing details on how your peers have successfully used simulation practices and tools to further their goals. Recordings of all the prior webinars are freely available online. The next one is scheduled for April 22nd, where ESRD will present on the important topic of simulation governance and its application to predictive maintenance scenarios. So please do join us. I'd like to conclude this presentation by celebrating a revolutionary Shirley Chisholm. As she said, you make progress by implementing ideas. You can't be a revolutionary from the sidelines. So please do join us at rev-sim.org and not just benefit from the community, but contribute as well. And with that, thank you for spending time with us today. I'd like to conclude and open the floor for questions. If you have any questions, please type them into the questions panel. Over to you, Joe.
Thank you very much, Malcolm, for the information on Revolution in Simulation, revsim.org. I did want to remind people that they can ask questions through the question panel. We'll be answering those. While we're waiting for the questions to come in, I did want to comment, and hopefully you and I can clarify to people what the relationship between the Assess Initiative and Revsim, Revolution in Simulation is. If you remember my introduction, the Assess Initiative chose that in order to make the impact it was looking to do, it wanted to bring together the key thought leaders to work on strategies, issues, approaches that could be used, and purposely chose to avoid any sort of thing that got into how to go about doing that at a detailed level. Malcolm was actively involved with the democratization work group, and we discussed together how there was a need for a set of resources to enable and help this revolution in simulation. And indeed, Assess was the first organization that indicated that there was a revolution in simulation that was going to occur. I'll refer to it as the simulation revolution. We still call it that. So in that session, Malcolm and I vehemently agreed that there was a need for such resources, and it became clear that Assess was not the location for that, but that Assess works with and coordinates with other organizations to provide the actual resources. Assess has collaborated with Revsim right from its beginning origins, and we are a sponsor of Revsim, and Revsim is a sponsor of the Assess initiative. So we collaborate on the concepts and ideas and the strategies of things that influence the increasing democratization or support the simulation revolution. And the Revsim takes on where Assess stops and helps enable people how to actually make it happen. Malcolm, did you want to take that any further?
That was well stated, Joe. And I'd like to reiterate that we've worked together from the start. In fact, our two organizations, Assess and Revsim, have also worked very closely with organizations like NAFEMS. And as Joe said, Revsim's role in this is to ensure that you as the end user are able to find all of the resources that you need, the education, the background, the case studies, the experts, the solution providers that you would need to take simulation to the next level within your organizations. And that was the need that Revsim decided to fill 3 years ago when it was launched in mid-2018.
Okay, so the first questions come in, Malcolm. How can I contribute content to the Revsim online community?
Oh, that's music to my ears. The heart of the community, of course, is the content that's provided. If you feel that you have content that fits within any of the topic areas or the theme of Revsim, please contact one of us. You see some of the email addresses right there on the screen. The first step, I would encourage you to sign on as a member. It's free. Just enter your email and you're in, and then send one of us some email regarding the kind of content you'd like to provide, either as an end user or as a solution provider.
Okay, the next question that's come in is, what are the value propositions for simulation as compared to traditional testing?
Well, as you saw in some of the application areas, some of them are more obvious than others. With traditional testing, you have a very limited amount of testing that can be done, i.e., you explore the design space and design behavior in a very limited way. Not only is it limited, it's usually quite expensive as well as time consuming. Simulation, on the other hand, when set up correctly, and especially with the use of automation, allows you to explore the design space much more extensively and automatically, as well as find optimal solutions that often may not be intuitive.
Since this is a question that's about an overall positioning of value as well for simulation and not just about Revsim, I'm also going to throw in and chime in from the Assess perspective. From the Assess perspective, testing gives us point data for a specific metric on a specific instance, and we can repeat that to try to find a pattern. Simulation actually provides us with the ability to get an understanding of behavior because it provides us the complete fields, it provides the what-if scenarios, and it provides the virtual situation. So there is much more understanding enabled, besides the fact that we can run it much quicker and it's much easier and it can be done in less cost. You don't have the cost of building the prototype, but even forgetting the cost factor, the benefit to simulation is an understanding of the behavior, which is much more than point-specific data. Okay, we're going to move on to the next question. It says, you say, sponsor, what are examples of things that Revsim does that cost money, or is sponsor just a cheerleader?
I'm sorry, Joe, could you repeat that question, please?
It says, what are examples of things that Revsim does that cost money for a sponsor, or is a sponsor just a cheerleader?
Oh, a sponsor provides a lot more than that. Besides the money that they provide, which helps maintain the site and the resources, maintain all of the outreach and marketing that's done. The sponsors often have experts in particular field of interest to the revolution. And so they've provided moderators, they've provided content, the expertise to go find content that is available across the web, related to particular topics of interest to them. And as moderators, have helped guide the directions that the entire Revsim initiatives take. So sponsors have played an absolutely key role, besides providing the relatively small amount of money that's required to keep the initiative rolling.
So the next question we have is, can we go to production based on simulation alone?
Joe, I'm sure you're smiling at that question. That's been a question that's been asked ever since simulation has arrived on the scene many decades ago. And while the answer is still probably no, companies I know of are moving very hard and strong in that direction. And for the simpler parts and assemblies, they're probably already there. For the much more complex products, testing is still required. But a huge amount of progress has been made towards eliminating most of testing over the last few decades. So that's an ongoing process, and it really depends upon the quality of the simulations that you run and the confidence that you have in those simulations. Joe, would you like to chip in there?
Yeah, I'm going to chip in there, and there's a similar question that is tied to, can we make design changes based on simulation alone? And the goal of simulation should not be to remove testing completely. If we were to try to achieve that, we would reach a state where we lose the ability to validate the simulation. However, the goal of simulation should be to optimize and minimize the use of testing. We don't have to test anymore 15 different prototypes of cars for crash. We test one. We should know exactly what's going to happen in the test prior to running the test. Any test that we have to do, it should purely be for validation. Some tests may be validating at a micro level about the material properties we're trying to put into the simulation. So we need to validate. Validation does not ever go away. How we achieve that can be significantly more efficient through the use of simulation. But there are exceptions to this. And the exceptions include things like nuclear energy and nuclear weapons programs, where you would think these are some of the most complex things. They literally cannot test them. So how have they achieved this? They've achieved this through simulation. Now, they've gone through extensive methods of doing validation, and they do micro testing for validations, but they can't test the entire thing. So it isn't like it's totally without test. It's that it's been minimized and optimized to really make sure it's the appropriate testing for validation. So that we're going to a point where the simulation is actually predicting what the test should do. There should be no surprises in a test anymore. We have all the simulation capabilities that we shouldn't be finding. We shouldn't be discovering emergent behavior in a test. We should only be validating what we already knew from simulation. So is it possible to make design decisions without tests, with a simulation alone? Yes, that's being done every day. Is it possible to go to production? For some things, yes. For some things, no. And it all has a lot to do with the criticality of the decision. It also has a lot to do with, is testing even viable as an option? So in general, it's a good guideline to balance the appropriate test and minimizing that. So there's another question, which is a parallel to this, which is, can I go to production without simulation? I'm going to give a quick answer, Malcolm, and you can give a longer answer. And the answer is, yes, you can if you want inferior products. But if you want to go to production with competitive products, and your competitors are using simulation to do optimization, to ensure fatigue life, ensure value of the product, and you're not, you're going to lose market. Malcolm, did you have anything to add to that one?
Well, let's just start by keeping in mind that lots of fairly complex products were created, launched, and successfully sold before simulation was even a word that we used to to talk about particular kinds of software. The Wright brothers invented the airplane well before simulation on a computer and computers existed. And these days, depending upon the complexity of the product, you can certainly stick with testing alone. However, the power of simulation has been evident for decades, and it is indeed the rare case these days where products continue to be created, enhanced, and marketed without the use of simulation.
So this ties back to the question about the value of simulation as compared to testing, the concept that I mentioned about understanding. And why is that important? Because data is that, data. Understanding provides information to enable more informed decisions earlier in the design process and more often. So the result of the understanding is better design decisions sooner. That's the value proposition of investment in simulation. The purpose for all simulation is to support a design decision that is either being made or has been made.
Well, Joe, there's also the entire new area of generative algorithms that produce, along with the simulation that validates that the designs work, produce shapes, architectures, geometries that designers would scarcely be able to even imagine or contemplate, let alone model using the traditional geometry tools. So here's a brand new area that takes design and the use of simulation entirely, or almost entirely, out of the hands of engineers who have thought a certain way and designed products a certain way for decades.
Generative design is a great application where it has, in the recent packages that are available to do that, that the actual requirements of the user are not about defining a simulation, but are about defining a use case, about defining a design scenario. in the available design space, and all the simulation happens behind the scenes, and they don't even know, they just get design options. So it is a major, potentially enabling technology for a significant increase in the use of simulation and democratization, because fundamentally the generative design user does not know that he's even running a simulation. And it doesn't need to know. There is
So I'd like to, I'm sorry, Joe, go ahead.
That is the beginning of the packaging that you've been talking about, Malcolm. How do we make this excellent expertise and capabilities empowering the decision process and empowering the application, but not making it a requirement for knowledge?
And just wanted to point out here, the third webinar from the top, the next generation compact heat exchanger design and simulation. In this webinar, given by N-Topology and ANSYS and others in the industry, they demonstrated how these generative design algorithms were used along with guidance from experts to create highly effective and non-intuitive heat exchanger designs. It would be an interesting webinar to listen to. You can get access to it on the Revsim site. Joe?
Yep, the Assess Initiative also did one of these webinars, the Assess Insight webinars on generative design and what the state of the industry is and what the requirements are to really make it deployable. So you can check that one out at the assessinitiative.com website as well. So I'm going to thank everyone for your time. I think we're going to bring this to a close. Malcolm, did you have any closing statements you'd like to make to the audience?
In closing, I hope you enjoyed today's webinar. And if you're so inclined, please visit rev-sim.org and join the revolution. Hope to see you there. Thank you.
So again, thank you to everyone for attendance. The next Assess Insight webinar will be April 8th. We decided to pass on doing April 1st for April Fools. And so, although it is the first Thursday, we'll be going on April 8th. And that will be Hubertus Tumashite from Modelon, who's going to be giving us some interesting insights into digital twins from a systems engineering perspective. So again, thank you very much, and I appreciate your attendance, and we look forward to discussing with several of you at the next webinar. Take care.